Let's go ahead and move on. Our next presentation is going to be with Per Kristensen with Tiny Mobile Robot and our own Mike McCarrick here. And we're going to go ahead. Hopefully you can hear me, Per. And yes. Oh, awesome. All right. And I did not get a bio from you. I might have got one last year. So if you wouldn't mind introducing yourself a little bit, and I'll probably let Mike do that as well. But Per, the stage is now yours. Anything that I'm forgetting about?
Doing great.
Okay. All right. Go ahead, Per. Thank you.
Okay, thank you. Yes, so my name is Per Kristensen, and I'm with the TinyMobileRobots. We're based in Denmark. I've been with TinyMobileRobots for a few years now. Still a very young company. Only the company was founded in 2015. So in robot terms, we're probably quite old, but it is what it is. Today, I'll just give you a short introduction to a new robot variant that we will have hitting the market in spring. It's called TinySurveyor Plotter. Today, I hope a lot of you are familiar with the robot that you see to your right, I expect, the one that's called TinySurveyor Terra. That would be the new name. Today it was only known as, until today, it was only known as TinySurveyor, but now it will be TinySurveyor Terra, and the new variant will be TinySurveyor Plotter. The two robots are in many ways very similar, as in what they do or are used for. The main difference being that the current robot that's in the market is a more off-road, all-round type of robot. Whereas the new robot coming out is more designed for being on-road, or at least have fairly solid ground underneath. It's not able to handle as rough terrain as the TinySurveyor Terra is. However, the new variant has some extra features around safety and connectivity that we're not able to offer on the current robot, and I'll get a little bit into details about that. So the potential for the new robot, the plotter, is basically pre-marking tasks such as for roads, parking lots, airports, but also indoor, and also to some extent doing aspect surveys the same way you do it with the TinySurveyor Terra today. Key features being, it's very fast. So marking speed will be around, I believe, 3 feet per second. It has quite a few safety features, so you can obviously, as the same as with the other one, it's remotely operated. But this one also has a beacon. It has some collision avoidance and also a fit a flag option. I'll get back to these details in a bit. Same user-friendly tablet for both robots. So if you know how to operate one, you will know how to operate this one as well. It can be guided with GNSS or Total Station, and as usual, it's brand independent. I know that Monsen is Trimble, but it will work with just about anything. Fairly lightweight, around 23 kilos, and using the same we support the same, you could say, data formats as with the current robot, which is DXF and CSV, and it is quickly deployed. So the main applications, first of all, road pre-marking. Also, when it comes to road, it's often also used for setting out for the edge for each layer of asphalt. And then once the final top layer is on, then pre-marking the final lines. The productivity gain is quite significant. You get somewhere between 5 and 10 times faster than what you will do with a person or with a string line and this kind of things. And you get on satellite, you could say the typical accuracy that you can expect, which is within the 0.4, 0.8 inches. Yeah, and airports as well, line work, especially airports in general, have it's a good use case for the robot. Basically, because airports always have to redo the lines and have always got line work to do. But also we see it being quite good for example, something like car parks as well. Same kind of thing. And also in construction scenarios for setting out for foundations, as long as it's a fairly compact surface, the new robot will perform well there as well. As well as going indoor, as we have the option of guiding it with a robotic total station. Right now, we claim 10 millimeter accuracy. We actually believe, and we're testing that as we speak, that we can get a slightly better accuracy with the new robot variant, because we have better wheel control with the new robot than we have with the current. I'll just skip the video. I think I showed that one last year, actually. So some of the highlights here. Well, battery is now stuck under the robot. You still get this minimum 8 hours work time on it. Now on the front, we have some ultrasound detectors. It's a more compact design than the current robot, so it's slightly smaller, although it actually is a little bit heavier. We have now a safety beacon on as well, and you either put your GNSS receiver on, or you put a 360-degree prism on if you're guiding it with the total station. Then we have the tool area. We also have an area there where you can actually store a few extra spray cans, which could be convenient. Side mount or center mount, same as with the current robot, works a little bit differently how we do it, and the wheels. So the side mount is slightly different. It can be basically switch from a center mount to side mount without needing a tool. Today there's some screws that you need to unscrew and then fix it again. This is done with finger screws and clamps now, and there is an extendable rod where we can actually seamlessly slide the spray tool further to the side. Maximum offset would be 23 inches. That would be to the left, because it's not completely center mounted today. So you can slide it in and out, and there's basically a ruler where you can then read off the offset, and then it will just input that into the tablet, so the robot will know exactly what the offset is, and then should be marking absolutely accurately. Finger screws to adjust the height of the spray tool as well. To date, it's also screws, but that will be implemented on the current robot as well. There in the front, you see the ultrasound sensors. So a little look from the top around some of the new safety things here. So there's a safety beacon now. Makes it more visible. It's a fairly small robot. A lot of roadworks, especially down at night, and the beacon will make it more visible than you could say the other variant today. There's a manual stop button and the ultrasound. If you're wondering about the yellow and the blue buttons, that's to test spray tool. There today on this robot, there are 2 spray tool connectors at least. We only have 1 spray tool on it still, but I'll get a little bit back to that. And then there in the back, there is a small tube where you could fit a flag, basically, if you want to make the robot visible from a longer distance as well. So we have some more connection options on the new variant here. As I said, we will have the option to actually connecting 2 tools instead of 1. Initially, there is only 1 tool available, but looking a little bit to the future, we hope to have more tools available for this platform. I can't get too much into what, but we have some things let's say in development. There you can turn on and off the beacon as well, and you can toggle between some modes for the beacon, so bursting or rotating and stuff like that. Also new is that there's now a 12-volt power outlet, so you could take power for a rover or something else. Same as a USB connection option for data, as an alternative to the RS232 that's on the robot today. As you can see there, it doesn't look like a USB plug, but there will be a little adapter included that fits there, where you can then plug in your standard USB plug. A normal USB plug is not possible to make watertight, and there's an electric box behind there, so we need to do it like that. Same tablet as we use with the same tablet software as we use with the current robot, the Terra. If you're familiar with that, there's no difference really. Same, you could say, way to operate the robot. Then I have a small video here, just to give you an introduction of the TinySurveyor Plotter. That's really it from me. Maybe we're catching up on the time then.
Yeah, nice job, Per. I appreciate that. Let me just take a look at questions. We do have one question here. Do you have? Well, it was a question about how much you were seeing this in the construction layout market. What has been your feel about that, Per?
We do see it there, but it's often used by a surveyor as well when it comes to that. Mainly because you need let's say if you're working on satellites, at least you need a georeferenced data file. You need the map projection in place and stuff like that. And so I would say the knowledge about these things is normally what a surveyor has. So often it's a surveyor that actually operates it. But it will do, let's say, the big tasks, the boring tasks for you. But it still needs I think Jonathan mentioned in his presentation as well, it needs the human skill, and then it will do the boring parts for you, basically. So I would more see it as a surveyor's tool than anything else, really. If people are to use it and they don't have surveyor skills, they normally need to understand a little bit about how to work with AutoCAD, for example. And that they need to understand something about map projections and these kind of things. So, yeah, some people
Gotcha.
sit down and learn it, but yeah.
All right, I appreciate. I think our next presenter, Mike, will probably touch on that a little bit as well. Just that the user interface part of it. All right, thank you very much, Per. I appreciate that. Let's go ahead and get the time turned over to Mike here. I'm going to go ahead and launch his PowerPoint. And you can run it if you'd like.
Okay, thanks, Troy. All right, so yeah, I'm Mike McCarrick. Been at Monsen for going on 9 years now. Started as a technical support person and have since moved into more of a sales role. Primarily just responsible for selling and supporting our allied products, which the Tiny Mobile Robot is a huge part of, and the two TinySurveyor models that Pierre has highlighted for us. And so what I'm going to present to you today is some of the new features that TinyMobileRobots has put into the application that runs their robots in the past 12 months or so. So even for users of the current TinySurveyor Terra, this might be informative. I know some of our customers maybe haven't updated and haven't explored these new feature types. So that's the reason for this presentation, to just try to highlight some of this and make sure everyone is getting, you know, everything out of the robot that they can. Don't go left. Okay, so this is the new app look. And so the first thing someone who's run the old version will notice is that the entire display layout is slightly different. So this top taskbar or status bar, I guess I would call it, primarily is where the difference lies. And so this is interesting because this is obviously the app view, but you actually need the updated firmware on the TinySurveyor robot to see this. So just updating the app to the current version will not change the layout. And you can see highlighted up there across the top, really what the main benefit out of this is there's more information displayed to the user at any one time. So you can see here.
Virtual screen.
Oh.
You can't see the presentation.
Yep. 1 second, please. We're gonna troubleshoot some display issues here for the virtual attendees. Oops. That one, right? Perfect.
There we go.
Looks better, yeah?
Yeah.
It's got the red box around it now.
Yes.
All right, so yeah, the taskbar here is, you know, so I got it boxed in red here. So that's the main difference. And the reason it's helpful is because it gives you all this information across the top. So here's kind of what it looks like unconnected. And then if I go to the next slide here, this is what it looks like when you're actually hooked up to your correction source and ready to lay out. So it shows you how the robot and the tablet are connected. So they communicate over internet or Bluetooth. So internet is not a necessity, but it does help the connection. And basically they communicate over VPN through the internet or through a Bluetooth connection. You can see the internet status to the tablet. And so that's just a cellular data connection through the SIM card that's in the modem of the tablet. And then here you see the important bit, which is really your GPS fix info. And the cool thing about this is if you're guiding the robot with a total station, this icon would actually change to like an instrument on a tripod icon, and it would show you how the connection status is back to that instrument. So in this scenario from the screenshot, you've got a GPS connected. You can see the speed that the NEMA message is coming in at, and then you can also see your robot battery. So it's all conveniently laid out for you. And another nice feature is it shows you down here some details about your geometries that you want to lay out. So the features in your design file, such as line length, and it'll even estimate like the time it'll take to paint them out for you as well. So aside from the display, probably the biggest feature enhancement is this multi-select, as we call it, feature. And so this allows you to choose more than one feature within your drawing file at one time. So previously we were limited to choosing one feature in the file at once, and then you would paint that with the robot, and then the robot would stop and wait for the user to select the next feature and then tell it to paint the next. So you can imagine if you're doing a huge parking lot with tons of different stalls, that might be very cumbersome to individually select all these different lines. And so now to get around that issue, we have this multi-select tool. There's different ways you can actually make the selections. And so let's see, I have this right here. So here you can see you can either select manually from the map. So I could actually take my finger and choose all these different lines. Or in this case, you have all these different stalls you want to lay out. Even just manually selecting them individually would be kind of cumbersome. So you can use the select button down here, and you can actually select everything either that's visible in the map screen currently or by layer in your drawing, as you see here. In this case, everything's just on this 0 layer. Troy, could you go back a slide? I don't know if I can get it from here. Thank you. And then the other thing I want to highlight here is you can go back one more for me. Sorry. You can actually dictate the way it's going to drive these lines as well. So I can change the order that it's going to drive these lines using these slider buttons right here. So basically I can just move these around by clicking on this button and dragging or pulling down beyond the next feature. And then here it's outlining how it's going to drive these lines. So in this case, it's going this direction and then doubling back and then going east again and then doubling back and going east again. But if you think about that logically, that's probably not the most efficient way to lay those 3 lines out. So what you can do is reverse the direction of this middle line, and then it'll do something more like this. Paint this, and then go to the next end of the next line, and then come back in the opposite direction of travel that it painted the first one, instead of doubling back and going the same direction for painting every time. So what the app does is it reads the direction of the line that was set in CAD. So the easiest way to program this out is to set the direction of the line that you want the robot to travel in CAD. Once you get it onto the tablet, you can change the direction of a line, but you have to do it one by one. So if you had 100 lines and you needed to swap the direction of 50 of them, you would have to choose every other one and then reverse them, which is not, again, and hopefully maybe we'll see some improvement on that, but currently this is kind of how it is. If you have a whole bunch of lines and you really want it to optimize the route, you need to think about that ahead of time when you're making the design in CAD. This is what it looks like just when you have a ton of features selected. Just want to give you an idea there. Then
You have to reshare that screen. We're not seeing it.
and of course I did this vertically.
I'll have to reshare this.
Sorry. So it's I was hoping to put it into the PowerPoint presentation instead of link to it, but PowerPoint crashed every time I tried to put it in there. So
It's okay.
This.
There you go.
So all this is showing is the same 3 lines I was just showing in the app interface. It's now painting these with no interruption and no extra input from me, the user, on the tablet. So basically the functionality is exactly the same as it's always been. We just now have the ability to get the robot to do multiple features with no interruptions.
You're using the internal GPS.
This is internal GPS, right? So most people are going to be using an external GPS, but this is a model just with the internal GPS and then an antenna on top. If you get that model, you actually configure your correction information, like for your BRS source, right in the app itself. Otherwise, you do that through your data collector for your survey equipment.
Might have to read.
Sorry about that. A little antsy on you.
And we're going back to your PowerPoint.
Yeah. All right. Okay, so that's the multi-select. Some other new things that have been added are some robot behavior settings. So there's this advanced section, and this is where most of the new features are. And one of the big things that we've allowed the user to do now is adjust the baud rate that the TinySurveyor will accept. So this is from your external survey equipment. And the reason this is really convenient is because different hardware and software combinations are capable of different things. One of them being the baud rate that they can export the data stream at. And so as Pierre mentioned, this is kind of a manufacturer agnostic product in terms of the survey equipment you're pairing with it. And so this just allows the user to quickly change this baud rate if they need something different. So I know Trimble Siteworks, for example, will only export a baud rate of 38,400. So if you're using a total station and Siteworks data collector to guide this robot, you need to switch this. But when you go to use your 986 to run it, you can go back to 115,200, because in that case, you're exporting the data stream right from the GPS receiver instead of the data collector and the software that's on that data collector. So it just gives you a lot more flexibility. We used to have to actually call the manufacturer to change that baud rate, so it's much more convenient. You also see this churn restrict, which I'll touch on a little bit more, but basically this is another built-in safety feature to get the robot to only turn one way. So if there's, some sort of obstacle or, safety hazard in the other direction, you can try to prevent it from going over there. And then there's also this auto resume on air. So what this would like, say you were using a total station to guide it, and then someone walked in between the robot and your instrument, thus breaking the prism link back to the instrument. This auto resume, basically, as soon as the total station picks up that prism again, the robot would continue on doing its painting task if you have this turned on, or you could have it turned to no, in which case it would just wait for the user to actually specifically tell it to resume on the tablet. So here's just some of your different baud rates. As I mentioned, it's really just depending on whatever, the capabilities of your survey equipment that you're using to guide this robot can do. And that's what will dictate the baud rate you use. Okay, churn restrict, as I mentioned. So, say in this case, you don't really want this robot turning right, as it'll go over here into that curve or whatever is over in this area. So you would only want to turn left in this direction of travel. I've got a video of that, but I don't really know. Okay, we're going to skip the video. If you want to see it, just reach out to me. I'll give you live demonstration or send you this video. But this was basically just a video of the same 3 lines, just the robot turning left every time instead of right. And lastly, the last big advancement that we've seen is the ability to support different NMEA inputs. So traditionally, we've always used like a GGA or pseudo GGA type data stream, and specifically GGA when using a GPS to guide the TinySurveyor. GGA is great. However, it contains a latitude longitude as the position coordinate that it sends to the robot. And so what that can do is it can create issues if you want to lay out local coordinates with GPS guidance for the TinySurveyor. Because basically before, since we're getting that lat long, we had to transform that into a known coordinate system, such as state plane, because that's what the tablet would understand. Basically what to make of that coordinate, how to line it up with the DXF file that you put on the tablet that you want to lay out. But now we can do this PJK message type. And so it's still coming from a GPS, but the big difference is that instead of the lat long, it's containing a northern easting. So it's got your grid coordinate in the message. So the TinySurveyor no longer needs to transform that lat long into a projected coordinate. It's just getting a grid coordinate from the GPS to begin with. And this allows you to not have to transform the data you want to lay out to a state plane coordinate system. So you can just keep it in whatever localization you already had, as long as it's GPS calibrated. You'll get the coordinate for this out of your GPS sensor. And then you actually set the projection on the tablet to none. And it's kind of like you're working off a total station, because you're just getting a coordinate and then staking out data with those same, relative coordinates. And so you can set this up in Trimble Access, which is kind of the top image here, or you can use the web receiver UI, the web UI on your GPS receiver. It's just a different option there. Not every GPS receiver out there will do this, but all the newer Trimble ones will. There is sometimes you'll see maybe a difference in the speed that it can output. If you do PJK, for instance, the Spectra SP85, it'll do GGA at 10 or 20 hertz, but it'll only do the PJK at a slower speed. So just something to keep in mind with that. And this is what it looks like when you set the tablet projection to none. Again, no need to alter your DXF file here, which is pretty big. Like Pierre was speaking to, you need someone, I wouldn't say you need a surveyor to run this. You need someone that has experience with survey equipment probably to run this. And I've taught several customers with no prior survey experience how to run this, because it's basically one of those things like, it's a pretty defined workflow. So instead of teaching you everything about surveying, if it's someone that doesn't have surveying experience, I teach you what you need to know to make this work, right? So you need to know this much out of a giant sea of, surveying knowledge that's out there. But this was one of the things that kind of raised that knowledge barrier, is because you had to know how to retransform, DXF files into projected coordinates if they weren't already. So helpful with that. And then this isn't really a new feature, but you can still do, basically you can create your own custom projection through a PRJ file. So instead of, in this case, you're still getting a lat long from your GPS sensor that's connected to the robot. But instead of transforming it into a known coordinate system like Utah State Plane, you can transform it into a custom projection. You just have to tell the tablet the parameters of that projection. The reason you would use this instead of the PJK is maybe, for instance, like a defined coordinate system for a job that you're going to be working on long term. So this isn't something you're going to go lay out, for a week or two. I would suggest the PJK for that. But if you work at an airport where you're always laying out at the same spot, but you have an airport specific coordinate system, you create a PRJ file for that coordinate system. And the big thing about this is you're still getting the lat long and you're using that GGA message, which actually includes like more GPS fixed quality info than the PJK, which can be helpful for quality control. And also you still get the base map because it's still a projection. So the tablet will still understand how to project your data on top of the base map. Whereas with the PJK, there is no like real projection because you're just getting that grid coordinate. And so you just have a black or a blank base map underneath your line work, if that makes sense. And, oh, I clicked there, but I think that's about it. These are some of the pros and cons. I really just touched on all these. So this is PJK versus PRJ workflows. And that's about it. It's 11:40. So I think, any questions or comments for me? And then after that, I think we're ready to break for lunch.
No, actually, we have one more presenter.
Sorry, never mind. I'm sorry.
Any questions for Mike?
Like how you had your workflow where you could pick multiple lines. Now I haven't done the firmware update, but I'm really excited about that. The problem I've noticed is if I don't go every direction the same way on like a parking lot, my start and stops don't even out. So when I'm going to do my striping, it doesn't work out. So I have to go the same direction every time. Is there some fix for that?
Yeah, that's a good point. So there's a line, spray, paint, offset, like start and end. And so what that is the time, it's a time offset between where the beginning and the end of your file or your feature in your file is and where the robot actually tries to start painting, right? So if you're going at 6 feet per second, say you have your robot turned up and you don't have that value set in the negative direction for the start of the spray offset time, then you'll actually miss the start of the line because you're moving, right? So by the time the paint mechanism actually actuates on this robot, because you're moving at 6 feet per second, you've missed the start of your line. And so and the thing is if you change the robot speed, these values will change because that speed just changed, right? So the offset time is going to change. And just like it applies to the start of the line, it applies to the end of the line as well. And so it's just a matter of fine tuning those offset time settings in your robot behavior for the speed you're traveling. But then again, like if you were to bump up the speed, theoretically those values are going to change. And so it's kind of a trial and error process is how I've always had to treat it.
That's what I've tried to do. I just wondered if there was a feature that actually just said paint beginning, paint end, no matter what. If I haven't figured that one out.
So I mean, there's different ways to go about it. I've seen some people loop the robot back and then start from the other direction.
That's what I do.
Yeah. But we should be able to dial it in just with those lines. It just is speed dependent, like I said. So it is a very sensitive setting, especially, if you're trying to hit those starts and stops. I mean, it depends what your precision is, just how hard it is to tune it in. But yeah, that's
Good question.
There's some fixes.
Care to elaborate? I don't.
So if your CAD file, you've got your lines going, especially if you've got your skip distance, when it hits that skip, it skips like the last 4 feet of the line. Right? Depending on if it hits in the skip.
Well, I don't do skips on mine. Like I'm talking
Okay.
like just
So you do a solid line?
solid line. I don't do skips on any of my lines. I just do solid line on my DXF.
So also then if you take just a small line segment that's like 500ths long at the end of the line, then it'll try to paint that same line again, and so it'll always hit the same line.
Oh, so you're you're creating just a little
Just a teeny little
blip
line
at the
segment
end of it.
at the end of it.
Just to clarify, Chad, you're saying you don't do skips. Are you not painting skips on the ground?
Hey, my line work is just my line work when I.
Right, that's a solid line. It's not dashed. But I think,
I
I think
painted-
Matt was
I
speaking to
painted
the
it,
same thing
yeah.
there. I think he's talking about a solid line, but a skip on the ground that you're actually painting, right? Yeah.
Yeah,
So I think you were speaking the same language there, but
Okay.
Well, there was a question about approximate price for the TinySurveyor. Terra, I guess.
same price as the Tiny, well, so the Terra and the Plotter have the same price point. So contact me for more info on that.
There you go. Very good.